Okay, so I just taking one EC2 mission, so I need to install that dependency. So first I am going to install ekctl. So it's done. Next I need to install kubectl. Okay. Yeah, both are done. Okay. Now we can directly uh, install Kubernetes. Okay, using ekctl. I'm changing the node count from 2 to 3. Okay, so I will get 3 nodes. I didn't attach my roles to the machine. I paid school is visible, right? All of you?
Yes, but it's very small.
Yes, it's visible.
Paint screen, right?
Yes.
Prometheus and Grafana. Okay. Prometheus and Grafana. So in this lab, what we will do, like we currently creating a cluster. EKS cluster. So after that, here we can see a master part and worker part. In this case, we have three nodes. Okay, 3 nodes. Node 3, node 2, node 1. So after the deployment of EKS cluster, we will install Prometheus and Grafana inside the cluster. Okay. So that's actually a deployment, like Kubernetes application deployment, similar like a deployment. We need to deploying Prometheus and Grafana to the cluster. Then we will access that Grafana URL. Okay, using take a browser. Then we will put the URL of Grafana to view and manage Grafana. So this is the Grafana UI. Okay, this is we work in a browser. Okay, different browser, and we put that Grafana load balancer IP here, and we can log into Grafana, and we need to provide the credentials of Grafana. After that, here we install two things. Okay, one is Prometheus, and second one is Grafana. So coming Grafana, we log in here. That's fine, but Grafana needs this Kubernetes metrics and logs and everything. Okay, so that's all taking this Prometheus service. So Prometheus sending all details to Grafana. So that all details we can see in the dashboard as well. So Prometheus here is collecting the logs and metrics of Kubernetes and sending to Grafana. So whenever we configure Grafana, we need to provide our data source. Actually, Prometheus will collect the data. So for Grafana, the data source is Prometheus. Got it. All of you.
Yeah, we're getting.
So Grafana can see it through Prometheus or directly from Kubernetes?
Through Prometheus.
This.
Okay. But yeah, you have one arrow going from the left to right from EKS cluster to Grafana dashboard, and you have one arrow going from EKS cluster to Prometheus.
But yeah, yes. This is the workflow, actual workflow. But in this case, the Prometheus here, okay, Prometheus will sending that thing.
Oh, okay. I thought it was able to get it from both levels. I think it has an option, right? You can directly get data also, and it can get it from something.
Without Prometheus, right?
Yeah, without Prometheus, also Grafana can get information, I think.
No, Grafana, whenever we configure Grafana, we need to select the data source. So there we need to select the Prometheus actually.
Okay.
Yes.
I have a question.
Yes.
Is all the companies follow that use that Prometheus and Grafana. Did any of the company use CloudWatch?
CloudWatch, right?
Yes, for monitoring purpose.
CloudWatch is specified for Kubernetes AWS account, right?
Yes, even CloudWatch is a monitoring tool, right? Which is available in AWS.
Yes, but most probably I can't see anything related to CloudWatch because most of them using third-party applications like Datadog or
Correct. Datadog, Prometheus,
right,
and
right.
Grafana. But
Because
any small companies,
yeah, that as of now I didn't see anything.
small application like that.
Yes,
Okay.
but we can use CloudWatch as well to monitoring resources like EC2 database like that.
Yeah, because around last month I was going to one of the requirement in the job requirement they were mentioning CloudWatch as well.
Okay. Yeah, some companies using I think that application like CloudWatch.
Yeah, is this possible to show us how do we need to configure in CloudWatch?
Yes, I will show you one lab for CloudWatch. Okay. So
Okay.
leveraging CloudWatch, how we monitoring
Okay.
resources.
Sorry for inconvenience. We did another quest for you. The stair top is gonna scratch the van. Sorry for inconvenience.
Sir, can you show how the real-time deployment was happen in real-time projects, entire process once?
I will check for any new deployment. Okay, as of now, all the companies are pre-stage.
Okay.
Yeah, Tawfiq, just want to know, how the requirement will come from the client and how the source code will come from the development team. So how the DevOps team is going to handle from there. Just end to end, we should know.
Understand. But now, it's a IT freeze zone right now for all the companies. So there is no new requirement actually.
Okay. Any small deployment in your company? No.
Right now we didn't create any change or anything happening these times after February, I think. All the deployments starting.
Okay.
But I can tell you the process. Okay, like what are the things always how they are deploying application. Okay.
Charging wire.
Deepthi, can you mute yourself?
Yeah, sure, Mahesh.
Yeah, Tawfiq, actually, you were telling something. It was background noise from Deepthi. I couldn't hear properly.
I mean, I will show. I can explain the scenarios. Okay, I mean how we are approaching the application deployment to different stages. I mean, starting from the dev to the production. What are the steps or what are the procedures that we follow and everything.
Okay. Yeah. Okay.
Okay. So that I will include in coming section. Okay, don't worry about that.
Yeah. Okay.
So successfully we installed Kubernetes cluster C with the 3 node. So now we are using Helm package manager to install Prometheus and Grafana, okay, from the official community. So Helm is a package manager, so that the package manager have lot of packages. Packages means, for example, now we are going to deploy Prometheus and Grafana within Kubernetes cluster. Okay, so any application we need to deploy to Kubernetes cluster, we need that YAML file, right? We need to create the YAML file, and after that we will apply the YAML file. But popular application, Prometheus and Grafana is one of the open source community based application. So there is actually a YAML file for that application deployment. Okay, so that comes under the Helm package manager. So we can just install the Helm. After that, we can inside the Helm package manager, we can see the packages for Prometheus and Grafana. So just we can install quickly using package manager. So in that case, we didn't create any YAML file for that. That's one of the benefit if you use Helm. So first we need to install Helm. Okay, successfully installed Helm. Now we are going to use Helm. Okay, using Helm command, we will try to add stable application packages. Okay, using Helm command. So Helm repo add stable charts. This table has added to our repository. Okay, let's see. Also, we need to add the same LM repos for Prometheus community. These are the Helm commands. Okay, so you can see Helm repo. That's after we installing Helm, we will get that command line. Now I am searching Prometheus community from that repos. Okay, so these are the related files under Prometheus community. So we need to choose our corresponding one. So we need to select, I think, Prometheus with the Grafana repository. Okay. So before that, we need to create a separate namespace for Kubernetes deployment namespace for Kubernetes for Prometheus Grafana deployment. Okay. So kubectl create namespace Prometheus. So the Prometheus namespace created. Now we are going to install the Prometheus and Kubernetes stack from the above repository, one of the repository. Okay, so the repository name is Prometheus community Q Prometheus stack. This is the repository. Okay, this repository we can see here above. Yeah, this one. This is one we are going to install. Hit enter. Reachable API client authentication failed. Installation failed. Kubernetes cluster unreachable.
Can you try reinstalling that kubectl? Install -y kubectl.
Sorry?
Can you reinstall again that kubectl?
Yeah. Yes, it's installed. Same error. Execute plugin issues.
Is the namespace issue?
No.
You have to identify the namespace.
No, same namespace here. You can see. This is existing namespace. We created the namespace actually.
Okay.
Mommy, hi, today's news. Yes, please. There's an excavator stuck in the middle of Ohio Bridge. Don got stuck in a hole. He got tripped in a big hole, big thread. He got tripped when he was trying to get that car. He tripped in his arm. Now please go save the excavator. He's waiting for animal rescue to come. Animal rescue has an important job. Please do it right now. Excavator got stuck. Look, Mama, me. The excavator stuck and he fell down. Mommy! Mama! Oh, now you need help. No, Mama. You need to get the excavator out.
Install community Diploma.
Is the kubectl is it compatible or incompatible? Is it possible to check kubectl version client? kubectl space version -- client -- short.
1.3. 1/3.
Mommy, look, when you look on there, you standing, you look on there, you take Mommy, Mommy, we need help. Mommy, can you? Mommy, this is the best thing you can find.
Yeah, I got it, but it didn't like that, it will break. It's
Hey, you have open the fridge.
So some problem arise on that machine, okay, actually. So to sort out, it will take some time to troubleshoot. Otherwise, we can quickly deploy one machine, okay. So that will be better. We can sort it out fastly.
Okay.
Next. And so I'm quickly do the all the things, okay? Like installation of EKCTL, installation of kubectl, everything.
When I do it.
So first I need to delete that existing cluster, okay? Because that the limitation is exceed actually. That's why. So this is the way we deleting our existing clusters using ekctl command. Ekctl delete cluster, then the name of the cluster and the region of the cluster. That's all.
So can we do it from console as well?
Console,
We can do that.
yeah, we can do that, but it's a lot of configuration there. So here we can do it with a single commands, like one line
Okay.
command for creation and one line command for deletion. But we need to install the ekctl and kubectl. That's all.
Okay.
It's very, I mean,
Yeah.
few time we can.
We have to go back to the Node.js. We have to delete, and we have to go to the cluster. We have to delete. Respective VPC, we have to delete.
Right.
Correct me if I'm wrong, Tawfiq.
Yes, you're right.
If you delete here, everything will get deleted.
Yes.
Okay. So did I join late?
Today we started at 8 a.m. actually.
Yeah, I just forgot about the timing. So what did I miss?
We tried to create a cluster, but for some issues there, so we will go with scratch again. Yeah, see, now we creating a cluster again.
So eventually I didn't miss anything, right?
No, nothing. This is for
Okay.
the lab. Prometheus and Grafana. Okay, we need to monitor our
Okay.
Kubernetes cluster using Prometheus and Grafana. So now you can
Okay.
see we creating the cluster only. After
Right,
that,
right. So we can use like monitoring tool like any, like this time we are using Grafana, but we can use Datadog or Grafana is
right,
specifically
right.
for graphs, right? Am I right, sir? Grafana
Sorry,
is
come again.
specifically for, so Grafana is specifically for graphs, graph-like presentation. Like if you
No,
wanna,
no, 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 no,
no,
no, not
not
like yep.
necessary. So any we can choose, like any organization choose any tool,
Yes,
depending upon their
yes.
needs and
Right.
requirements.
Right.
Okay. Okay. Sir, I have one question apart from the current topic. So I just came across one of the term Azure DevOps backlogs. So this is a service which we use when we use Azure, right? So I just need to know if I need to use AWS, then what is the compatible, service we will use in AWS in this case?
Come again.
So
Which
there is a
service?
serv so there is a service in Azure cloud named as a DevOps backlogs, which we use for having a track on the backlogs. But the
Hmm.
name is DevOps backlogs. That's what I saw in Google. Okay, so
Hmm.
but I want to use because I'm using like making my profile accordingly AWS. So so what term I should use? Like what kind of service which is doing the same type of job in in case of AWS?
Actually, coming to Azure, there is a Azure DevOps service there. Okay, so I think that's came under that part, right?
Azure DevOps service.
Yes, that is called Azure DevOps. So we need to create a separate service actually. That is called Azure DevOps. Then we need to create a Azure organization there. After that, uh, we will creating the CI/CD pipelines and everything under the Azure DevOps. It's a separate umbrella actually coming to Azure. So there
So
we can see
this,
Azure board, Azure the logs, everything we can see there.
okay. So here, so in case of AWS, what service we use for work like for doing this kind of work?
We mean the CI/CD, right?
I don't know like what it does. Like it says like DevOps backlog. So when I went to this try to search in Google, it was showing the backlogs which the DevOps do, the logs basically.
Google Elastic backlogs. I need to check that actually. Wait, give me a second.
Okay. Or maybe I'll show you later after call.
Sure.
You know? Yeah, okay.
Per my knowledge, Azure backlog means that there are multiple releases on pending, and DevOps team is going to prioritize which needs to be delivered first. The
Right.
DevOps team is going to prioritize the pending items.
Right.
So
Yeah, so actually, whatever you're saying that aligns with the statement here. So it says like build a strong stakeholder relationships, prioritize Azure DevOps backlogs, and align projects with the business and compliance goals. So I think whatever you're saying that
correct.
goes accordingly.
Yes.
Okay.
See,
So the question is, what kind of like what should I write in case of AWS? Because I'm writing everything with the
in this case, there won't be a difference in AWS or Azure. Only that the tool which we are using to keep all the pending items it will different. Here we may use Zira in DevOps also. We may use Zira in AWS Azure also. Only we are going to prioritize that one, which needs to be released first, which needs to be go next, which one we can keep it as a pending. So that is the backlog which we are going to follow based on the client requirement or the business needs.
So
whatever.
This is not a name of a service, Azure DevOps backlogs. This is not the name of the service, right?
No.
There is
no
this
any
is a
service.
This is a kind of work which the person does with the help of a Jira
Yes.
and other.
Yes.
Okay, just it is basic in a very vague language. We can say it is tracking the logs, like backlogs and prioritizing what needs to be done first.
Logs altogether, logs is different actually. Logs means whatever work is monitoring, whatever the work is doing, the every second the application is running, where it is stopping, where it's lacking, that is what we monitoring, that is called logs. So here, for example, you have around multiple 3 change requests you got it from the client. Out of 3, you need to, as a DevOps engineer, you're going to prioritize that one based on the you will talk with your supervisor or manager and your client advocate or client, which one need to go first, and you will start working on that one.
So what do you mean by backlogs? Logs and backlogs, what is the difference between this?
Yeah, see, that's what I'm telling. Backlog means you're going to, there are around 10 change requests you got it from your client. In this month you release 2.
10 change requests, like changes needed. Okay.
Yeah, there is application is running. You got a request from the client that changes need to be done in this one. Only you are able to do the 2 in this month. Rest 8 is a backlog. It is in the backlog. All of a sudden you got one more. All of a sudden you got one more from the client. That is a high priority. That is because high production issue is there. That needs to get it fixed as soon as early. So you keeping all the 8 as a backlog, and you're working on the high priorities one.
So basically, it is a pull which we gonna pull it, right?
Correct. Yeah, which one
we're gonna pull it like as per prioritize. Yeah. Okay.
Yeah, every day you'll be having a call. In that call, you'll be discussing which one we need to work on, that one. When do you need to start? What is that time you are giving for that?
Yeah, the Scrum meeting, during the Scrum meetings, right?
During the Scrum call, you can discuss.
Yeah. Okay. Thank you, Mahesh.
Bye.
Sorry, sir, for holding everybody during the class.
No problem. We are currently creating a class actually.
For log, it will be different. For every application, every application is running, you'll be having a log file where you can check every second what is happening. Manually, you can go and check. If you want to do monitoring through application, you can go check Grafana or Datadog.
I think we are stucking on EKS creation, right?
Yes. Cluster creation, we are stacking. Instead of this, we can use T2 large.
2, 3. Yeah, it's taking actually. It's 6. Yeah, it's progressing actually, but little slow. See, it's progressing. Okay, sometimes it will take some time. I think this depends on the cloud formation. Actually, what will happen using ekctl command? AWS have native automation tool called cloud formation. Okay, so the cloud formation automate this process, automate the deployment of this EKs. Okay, so that's we can see here. Go to the cluster. Go to the cloud formation. So this is the stack actually that we currently running. EKS clusters, ES cluster. EKC test ES cluster. Okay, so here we can see all the events, other things currently doing everything. This is similar like a Terraform. Okay, like here actually using cloud formation stack, it will create EKS cluster. Okay. See, our cluster is up and running. Okay, fine. Now, next thing is we need to install Helm Package Manager. Okay, so leveraging Helm Package Manager, we can easily installing Prometheus and Grafana. All are following, right?
Yes, sir.
Okay. So after installation of Helm Package Manager, we need to search for or adding the stable charts, okay, from the Helm repository. So it's added all the repository. Now from those repository, we need to check for our required Prometheus community-based repository. So that repository contains that packages to install that specific application, okay?
Sir, I have one question here. What is a Helm repository here? Like, is it specifically for Grafana and
No.
Prometheus?
Helm Package Manager is a tool for deploying Kubernetes application. Okay, for example, now we successfully installed Kubernetes, but after that we need to deploy application, right? So we need to write YAML files. So now we are going to install Prometheus and Grafana into our Kubernetes cluster. So we need to create a YAML file for those application deployment. So that's it's a time-consuming process to write up the YAML file for a community-based application. So we will get the applications repository if you're using Helm Package Manager. Helm Package Manager is a package manager, contains lot of packages. Packages means lot of application packages. So we didn't create any YAML file. That's one of the benefit. We can just using the repository and we can deploy application using Helm.
So Helm Package Manager we install in case if we are using Kubernetes.
Yes, most probably this
Yeah.
package manager is most probably for Kubernetes actually, because that package manager contains a lot of YAML files, open source application YAML files, like that.
And it doesn't matter whether it is a self-hosted or
Yes,
through
no problem,
AWS.
no problem.
Doesn't matter. So in
Yes,
any case, if we are using Kubernetes, we have to do it, and we gonna use Kubernetes for sure, definitely.
right.
Yeah.
Tawfiq, even though if you don't use the Grafana and Prometheus, do we need to use Helm Package Manager?
Yes, now we are using Helm Package Manager to install Grafana and Prometheus. See here we can see the now we are using Helm Repo. Add what? This Prometheus
My
community.
question is, so if you're not using Grafana or Prometheus, do we need to use Helm Packager? Not required, right?
This is Helm package is not for Grafana and Prometheus. We can use lot of we can deploy a lot of services like similar like Grafana and Prometheus.
Okay.
Yeah. This is
Lot
not
of
specific
services
for. This is
sorry
not
to interrupt you,
specified.
sir.
Yeah, this is not specified for this application deployment like Prometheus and Grafana. For example, if we need to install some other agents, lot of services there. So coming to organization perspective, we mostly using these types of LM package managers, like to deploying different services.
So in case of Datadog also, we can use this thing?
For Datadog, we didn't install LM package manager.
We don't. Okay.
No.
Okay. So just these two or maybe other like
Right.
can.
Yes.
Okay.
See, now I am searching. I added Prometheus community repository. Okay. So after that, I am searching using Helm command, Prometheus community. Okay. From the added repository. So it will listing lot of repository there. So we need to choose corresponding service. Okay. If you need Prometheus Elastic Stack, we need to go with that one. fastly exporter there, Kafka exporter there. So in our case, we will go with the third one, right? Yeah, Kube Prometheus stack. This is the one we are going to install. So this repository contains a YAML file. So before that, we need to create a namespace. I'm going to create a namespace, okay, for this application. So that application corresponding to the namespace Prometheus. Now I am going to install that application using helm command. So this will deploy the application into Kubernetes cluster. Okay, see, the deployment is actually running. So these are the related services. Prometheus exporter. Okay, stable Grafana there. Yeah. So we need to access the application. So I'm using service, checking the service, get SVC. You need to mention the namespace as well. Okay. Format PHUS. Okay, here you can see these are the services for our application. Like these are the services whenever we installing that Prometheus and Grafana. Okay, so in this we need to access that Grafana one. Okay, see. So here you can see that cluster IP. Sorry, cluster type. All services is using cluster IP. So I hope you all know the types, Kubernetes services type, right? All of you. So in this case, all the services having the type is cluster IP. So here you can see that services 1, 2, 3, 4, 5, 6, 7, 8 services are there. So we need to expose the Grafana service. So expose means expose to internet, so that we can access that Grafana using browser. So we need to change the type as load balancer. Okay. So we need to edit. So using the same command kubectl edit svc, then the name of the service. Okay. So then we will open, a editor. So here you can see the type. Type is cluster IP. So we need to change. This is nav editor, I think. Type insert I to insert. Then type load balancer here. L capital. B also capital. Balancer. Escape. Save and exit. Yeah. Now I will check again. Okay. See, now we will get a IP. External IP URL for the load balancer. So this will be used for accessing Grafana. Copy and paste. It will take some time, but in backend actually our load balancer is creating. Okay. The time when we changing the service type to cluster IP to load balance after only the load balancer creation. Yes, now it's loading. So the default username is admin and default password is prom admin. Okay, the login. So I am successfully login. Close. So when first, this is a dashboard of Grafana. Okay, you can see my screen, right? All of you.
Yes.
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 So this is the dashboard. So as of now, we didn't onboard anything. So we need to onboard our application or what are things that we are going to monitoring. Okay. So here we can see import dashboard. Okay. Before that, we need to add the the data source. So just go to connection, add a new connection or data source. Okay, click on that. Prometheus. Okay. So I'm just clicking
What
on
was
import.
that number? 1274.
This is actually a ID. Okay, that ID related to specific services. So I'm choosing one ID. So that ID is corresponding to Kubernetes monitoring dashboard.
So
Got
where we
it.
can find that ID, sir?
This ID we will get from Grafana actually. See, just to go to Grafana. Grafana ID for Kubernetes. So here we will, from the official document, we will get the ID actually. I will share the link. Okay, this is not the correct one. See, cluster monitoring Kubernetes. So here we will get the ID. See, import dashboard template. I will share the accurate one. Okay. So now we onboarded. We type one ID and that ID is corresponding to Kubernetes monitoring dashboard. Then here we need to select the data source. Select a Prometheus data source. So here we can go with the default one. So because that Prometheus is running on our cluster. Okay. So this Prometheus has our default one. So click import. So that Prometheus will getting all the details. See, this is the dashboard we will get total. It will take some time to fetch all the details like cluster memory info, CPU info, and everything. IO pressure we can see here, network IO pressure. Then CPU usage, container usage, container memory usage, network usage. This is all process CPU usage, okay.
Tawfiq, how do we check the resource and limit here? Like 250 MI, 500 MI, we did check it manually in the last class.
Yeah, that we didn't complete, right?
Yes.
That coming section I will include that, okay. We have a section on like deployment strategy. So under that one, tomorrow we will go through that. The
Okay.
limit and request, right? So here we can sort out that for specific namespace as well. Okay, like in this case we have this all namespace, the node, all node. So it will shows only based on the namespace as well. That deployments.
Actually, resource and limit, you already completed the last class, Tawfiq.
Yeah, it's completed, but we didn't deploy. We didn't check that final output. So mirror, I
Correct.
think. Yeah.
Yeah, we didn't check it in the Grafana.
Hmm. The
No,
max
no.
and the limit, right?
Right.
Max and min, yeah.
Max and minimum.
Hmm. Yeah, we just created and we didn't check it like how it looks like in the monitoring tool.
The final part we miss, like we manually stress some load to the containers, okay, or the pod. So what will happen? Before that we set up the limits, right? The maximum. So whenever we pushing manual stress, the amount increase. Exceeding that maximum. So what will happen? The container or the application container goes to throttle state. That's actually I am showing in that previous one. This throttle stage, okay, how the container goes down like that. Got it, all of you?
Yeah, got it.
So tomorrow we're gonna see that how it looks like.
Yep.
Okay, so
Then we can wind up today's section, right? All of you.
Thank you for the class.
Yes.
Have a good night, everybody. Good
yes,
morning,
sir.
Professor.
Yeah.
Yes,
Bye all.
Sir,
Yeah.
sir,
Bye.
when can we have a videos? It's like we don't remember.
Today I will share.
Oh, you got it? Okay,
Yeah. Yes.
great. Thank
sir,
you.
can you provide some mock interviews?
Yeah, I will. We can do it on one of the section. Okay, like a mock section.
Okay, sir.
Yeah. Bye.
Okay, thank you. Bye.
Bye.
Bye.